I want to give you a background of where they come from. First chain alkanes are acyclic alkanes. So we are going to, in this video and the next one, we will be focusing on acyclic alkanes, which we know acyclic means open chain. These things will not be in a closed chain. It will be an open chain, right? And acyclic are broken into two: straight chain, which is simple, straightforward, nothing added to it, and branched chain, which means there's a substituent group. So these ones we have a prefix. This second type of acyclic chain. Let me just show you the structure. We are looking at alkanes. Okay, alkanes, this is the homologous series, and these are going to be broken into two. In this side, we are going to have cyclic ones, okay, which we know when we name them, we call them cycloalkanes, okay, but they are cyclic alkanes, okay. And then we are going to have acyclic, which is what we're looking at right now, acyclic or open chain alkanes, right? Now, these acyclic ones are going to be broken down again, okay, and they're going to be broken down into two. What is the cyclic going to be? It's going to be straight chain, which means nothing is added. We're going to see it just now when we look at them. Straight chain. And the other one is going to be branched chain, okay, branched chain. And so that's what we're doing. We have to apply IUPAC to this homologous series called alkanes. But for us to apply to the homologous series called alkanes, we must apply to each subdivision one at a time. So we start with straight chain, then we look at branched chain. When we've looked at, sorry for this, what is happening? When we've looked at straight chain and branched chain, okay, now we'll look at the first group, the easiest group, the most basic group, right? The straight chain alkanes. These are also known as the normal alkanes. They're the normal alkanes. Nothing fancy is happening, okay? Why do we call them straight chain? I want you to make sure you put the name again. Please put the name close to your memory because it can go. Many names are going to be learnt, okay? Names, just like we're doing alicyclic and all these other guys. Please put the names somewhere safe in your mind. Take them seriously. Just go to straight chain. Easy. Why? Because it's the normal. We said we also call them normal alkanes, or we also call them N-alkanes. Okay? Now, why are they called straight chain? Why are they called straight chain? It's because all your carbons will be connected in a continuous carbon chain. By continuous, we mean that, we have the word continuous in maths, right? And we were saying it is something that you can plot or you can draw without lifting your pen. You can go start to finish without lifting your pen from the paper. In this thing, you can think of it that same way to say you can connect your carbons. If you were to draw a line connecting your carbons, you could do that without lifting your pen. You could connect every single carbon. Connect them through their bonds, of course. Connect them through their bonds without lifting your pen. Maybe let me show you. If I do this, if I have carbons like this, okay, whatever they're doing, I can connect them through their bonds like this. Carbon to come from this carbon, go to the next through its bond, then go to the next through its bond, to the next through the bond, to the next, let me do it again, like this, like that, through the bonds, right? Through the bonds like that. I can do that. What about if I have a carbon like this? I have a carbon here, then it comes like that, whatever happens. And then let's say here it comes, there's another carbon. Can I connect these using a straight line? Let me try. I can come like this, like that, and go to the end, okay? One. I can't take that other carbon. I can come like this. Let me put the second one. I can come like this and like that. Can you see that? I'm sorry. Can you see that I have missed, right? If I draw using the blue line, I would have missed this carbon. I can't connect him. I can't come and go to this carbon, then go back. There's no way back. I can't come back the way I came, right? So you can see that this is not continuous. So we say it is not continuous, right? Continuous means all carbons, we are talking about carbons here, all carbons are connected in a continuous carbon chain. Then we say we have straight chain alkanes. Remember, alkanes only have carbons and hydrogens, right? So now we'll be saying all the carbons in this alkane are connected in a continuous chain. If you have it like that, then you can call them straight chain alkanes. There is no branching. There are no substituents, right? Good. Now these alkanes, these normal alkanes, these N-alkanes are so useful to us because we use them as starting reactants or as reactants in as starting materials or as reactants when we make things like polymers. You know, polymers are plastics, right? Or when we make things like solvents or whatever it is that we're making, we use them as reactants or the starting materials. So they are very important to us, these normal basic alkanes. Now, their naming, since they have no substituent, that means they have no prefix. So that means we normally say that IUPAC is prefix plus parent or root, right, plus suffix. But in this case, we don't have prefix. So it's going to be parent plus suffix. Why? Because they have no substituent. And we know the suffix, I'll tell you now, for alkanes, we have done it. I'll say it again, is going to be dash ANE, right? It's going to be ANE. This dash just means something will come in and join. So let's say it's going to be ANE for alkanes, right? So we know the surname is ANE. Now that means the name of these guys are affected by their parent names, their root names. Okay? Because they don't have a prefix. So the only thing that can affect them is the parent name. So the main thing for us in this time is to know the parent names for each of these guys. And we know parent name depends on the number of carbons. Okay, so let's go through them. Starting from 1, we go 2, we go 3, we go 4, we go 5, 6. Maybe I'm going to have to put a line. I'm sorry for this. 2, and then we go to 3, and then we go to 4, and then we go to 5, and then we go to 6, right? Something like that. Then we go to 7, and then we go to 8, make them bigger, and then I'll go 9, get bigger like this, and then I'm going to go say 10, right? I'll make it bigger like that, and then I'm going to end at, I'll say 11, and then I would end at 12, right? I'll end at 12 like this. Let's name them. 1 carbon, right? What would the structure look like? Maybe we can start there. 1 carbon, what would the structure look like? So we know that carbon has 4 bonds, right? It forms 4 single bonds. This time we only have single bonds because alkanes are saturated, meaning the carbon bonds to the maximum number of hydrogens possible, okay? It will just bond with the other carbon to make sure the link keeps going, and every other space that's left will go to hydrogen. So if I were to put this first carbon had 1 bond with the hydrogen, with the carbon, so it needed 3 more. So it's going to need 3 hydrogens like that. Now this carbon at the center can only get 2 because he has 2 bonds, 1 on the left and 1 on the right with carbons to keep the chain going. So he can bond with 2. So we know if we are putting our carbons, would say CH3 is for the carbon at the end, and the middle ones would have CH2s. Now, since this one only has 1 carbon, it's going to be 1 carbon with 4 hydrogens because carbon forms 4. So when we write it, we say CH4. The suffix we know is going to be ANE, doesn't change because the surname comes from the family, which is alkanes. Prefix now, for 1 carbon, we use meth. And this is what we're going to use for the whole thing, okay? Our prefixes are going to be depending on the number of carbons. Not just for alkanes, the prefix is the Why? Why did I say prefix? Prefix is the word you used in high school for this. But prefix is not what we are talking about. Prefix comes from substituents. The parent, okay? The parent comes from the number of carbons. So I'm going to have to keep that word prefix out of my mouth. The word parent comes from the number of carbons you have. Parent comes from the number of carbons you have in your longest chain. So we can go through the parent names without even putting the alkane chain. When it's 1, we call it meth. Then when there are 2, we call it eth. Okay, never forget that eth something, whatever it's going to be. 3 is prop, and 4. These words are not related to anything. They're for the first 4 carbons. Okay, prop and bute. These words, okay, I'm not sure what you'd find them related to, but we don't have anything that we have learned so far, according to what I know, that have these words. But as you start from number 5, even when we are going to be drawing the shapes, they're going to be linked to plane shapes, polygons, which means shapes with many sides. And the names of the polygons are going to be the names we give these guys, but we only take the first part of that name. So if you're not sure, you can go and practice on polygons and naming. Okay? If you know that, then this would be easy for you. 5, we know a shape with 5 sides was called a pentagon. We are only taking the first part, which is pent. 6, it was hexagon. We are only taking the hex part. 7 was heptagon. We are only taking the hept part. 8 was octagon. We are only taking the oct. 9 was nonagon. We are only taking the non, N-O-N. 10 was decagon. We are only taking dec. Right? 11 is undec. 12 is do deck. Okay, that is done. So these will be your guys. I hope you can understand that. Okay, now what would we do? We'll start now giving. We know that their suffix would be A-N-E, so we don't even need to see their structure. We just know that if they have 1 carbon, that's whatever. So we can already know the names of these guys from just the number of carbons. Yes, for straight chain alkanes, it's that easy. A-N-E, 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 A-N-E dash A-N-E. So now when we put the names, meth and ane would be methane, right? The IUPAC name is now easy. Eth and ane would be ethane, right? So the IUPAC name of this simple carbon with 2, simple straight chain alkane with 2 carbons is ethane. Next is propane, which makes it propane. Next is butane, which makes it butane. Next is pentane, which makes it pentane. Then hexane, which makes it hexane. Then heptane, which makes it heptane. Right? Keeps going. Octane. Nonane for 9. Decane for 10. Then undecane for 11. And finally, for 12, it will be dodecane. Okay? And now when you put the other guys, we know that the carbons at the end when it's a chain are CH3s, and the carbon at the center is a CH2. So this guy, since he has only 2 though, that means the 2 would be at the end. So it will be a CH3 and a CH3, there's nothing at the center. But now we would have CH3 at the end, CH2 at the center, and a CH3 at the end. Then for 4, CH3, CH2, another CH2, and then a CH3. 5, CH3, CH2, CH2 makes them 3 now, CH2, 4 now, then CH3, 5. Okay, 6, CH3, CH2, they're now 2, CH2, they're 3, CH2, they're 4, CH2, they're 5, and the last one is a CH3, makes it 6. 7, CH3, 1, 2, 3, 4, 5, 6, and a CH3 at the end to make it 7. 8 is again the same thing. 1, then the second one is a CH2, 2, 3, 4, 5, 6, 7, and then 8, CH3. 9 is going to be CH3, 1, then CH2. 1, 2, 3, 4, 5, 6, 7, 8, and 9 will be a CH3, right? Then for 10, we put the CH3 at the end, then the middle ones, of course, are CH2. So that'll be 2, then 3, then 4, then 5, 6, 7, 8, 9, and 10 will be a CH3. Do the same for 11 and 12. We could do that. Let's go ahead. CH3 is the 1. CH2 is the center one. 3, 4, 5, 6, 7, 8, 9, and still 10 and 11 CH3. 12, let's go for it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my. We're almost finishing. 10, 11, and the CH3 at the end to make it 12. And that's it. Okay. Basically, that's how you name these guys. Simple, guys. How do I name it? You just look at the number of carbons and you're done. So straight chain alkanes, there's actually nothing, but they helped us to know the pairing names using the number of carbons. That's mainly what it is. Let's go see some guidelines when we now have branched and we see each and every possible scenario to make sure you're ready. Okay? Bye for now. See you in the next video.